Hi, George.
Mowing the lawn, eh?
Trying. Hey, George. It sounds like you got car trouble.
Yeah, I don't know what the problem is. It's just running real rough.
Oh, pop the hood and we'll check it out.
Oh, no, I don't think so.
Come on, pop the hood, George. Pop the hood. It's probably just a loose wire, George. I fix this kind of thing on my car all the time.
Well, I don't know. You know, I never had any trouble with this car before. I guess I just should have been paying more attention, huh?
My brother has a garage. You ought to go see him. Besides, he could use a business.
Gee, I don't know.
Oh, just tell him I sent you, okay? He'll take care of you. Let's see. Maybe your throttle gadget needs adjustment. Let's have a look-see at the old owner's manual, huh?
Oh, no, really, Ralph, that's okay.
Lucky thing I came over, George. This automotive stuff can get pretty complicated. Okay, let's see. Where am I gonna start here?
Auto dimensions, huh? Never did take the time to look through this. Hey, wouldn't it be great if this guy really could explain how my car works without all that technical stuff?
Wow, that was incredible. Where am I?
Welcome to Auto Dimensions, where all things are possible and you can see your car as never before. As your guide, I'll do my best to help you to understand your car's systems. All these systems: electrical, ignition and fuel, cooling, steering and suspension, brakes, and preventive maintenance to keep all those systems in good shape. And choosing your service partner for the checks, adjustments, and repairs you can't do yourself.
Well, great, but all I really know about my car is how to drive it. I mean, everything else is pretty much a mystery to me. What's worse is I got this know-it-all neighbor.
I've seen him.
And he's got this brother.
Who runs a garage.
Yeah.
Well, George, what you really need is to know more about your car. Wouldn't you agree?
Yeah, I think you're right. But like I said, my car's a mystery to me. So where do I begin?
We'll begin right here. See, our goal is to view all these dimensions for a complete view of how your car operates. Of course, even though we see each system separately, they work together so that your car runs smoothly and efficiently. So where we start is up to you.
Well, how about electrical?
Okay. The electrical system. It generates and harnesses electrical energy, electricity needed to run the engine, and much more.
Well, hey, even I know my car uses both fuel and electricity.
Well, that's right, George, but each is supplied by a separate system. Let's take a closer look at just the electrical system. Look familiar?
Wow, I've never seen a battery that big before. Well, you said anything's possible in auto dimensions.
Well, George, the battery is where your car stores its electrical energy.
How?
Chemical action, that's how. Now, you wouldn't do this at home, but just for demonstration purposes, let me show you.
What are those things?
Lead plates.
Lead makes electricity?
Not by itself, George. We need two other ingredients: water and sulfuric acid, which is a powerful acid and can cause serious burns if it touches the skin. This mixture of water and acid is called electrolyte. It chemically reacts with the lead plates to create...
Hey, electricity. All right, well, what happens if this liquid, this electro...
You can just call it battery fluid, George.
Okay, what happens if the battery fluid leaks out or evaporates? Then what?
Well, then no more electric power. Fortunately, most car batteries today don't need periodic refilling like older ones. But it's a good idea to have your battery checked when you take your car in for service.
That makes sense. But doesn't it get weaker as the electricity gets used by the car?
Uh-huh. As electric current flows out, the battery gets weaker.
Well, then what keeps the battery from getting too weak to be any good?
Well, as the engine runs, the electrical system puts energy back into the battery. To do that, the system uses another basic component called the alternator. Come on. The alternator produces electric current, but only when the engine is running. It's driven by that belt. When the engine stops, the belt stops moving.
And the alternator stops producing current.
The alternator is connected to the battery, which stores the electrical energy. That's called charging the battery.
I get it. Does the alternator's voltage change when I drive at different speeds?
Good question. To make sure the battery gets consistent voltage, the alternator has a built-in voltage regulator. It works as a control to prevent overcharging the battery.
So then if I do have an electrical problem, it's not necessarily the battery. The alternator or the voltage regulator might be goofed up.
Right again, George. But you can avoid problems if you keep the entire electrical system in good condition.
Okay, but how do I get my engine started in the first place? Does the battery do it?
Well, I think you can get your answer with these.
Keys? Okay, where's the car?
Right in front of you. Go ahead, turn the key.
Hey!
That's the sound of your starter motor. It's what really gets the engine moving. It runs on electricity.
So then the battery doesn't start the engine, it starts the starter motor.
When you turn the key, a switch sends electric current from the battery to the starter motor, which then turns the engine. The engine only needs a few turns to get started.
Well, what keeps it running?
Well, that's part of the ignition and fuel system. That belongs to another dimension, so be patient. There's still a little more to know about the electrical system. Take a look at this.
Wow, all those wires. Now, I know they must carry current, but where do they lead?
Well, that depends. Your car's electrical system is a lot like your own nervous system. Each wire carries current to components that need electrical energy to operate. Let's look at the headlight circuit, for example. Turn on the switch, and current flows into the individual headlights.
Okay, that's the headlight circuit. But what about all the other things in my car, like the wipers, the turn signals, the radio? Do they each have their own circuit, too?
Yes.
So each circuit has its own switch to turn it on and off. And when it's on, the current flows through the circuit wires to whatever part I want to work.
Right, George. Now, let's go.
Go? Go what? How'd we get here? Don't tell me. Anything's possible in auto dimensions. Hey, that's the instrument panel.
Yep, and it's part of the electrical system you see most often. The switches are grouped together so that they're easy to reach. Let me show you how much your car relies on its electrical system. The electrical system also has warning lights to tell you about the engine temperature, oil pressure, and battery charging. Speaking of warnings, let me show you something important.
Well, what's that on the battery?
That's corrosion, George. It's something like rust, and it can lead to problems in current flow. Corroded connections can cause lights and other electrical equipment to behave intermittently or even fail.
Well, don't keep me in the dark about all this. Tell me, what can I do to keep my electrical system in good condition?
Well, there are 3 simple checks you can make. 1, check for any corrosion, primarily on the battery posts and cables. You can clean the posts with a battery post cleaning brush, available at auto supply stores. 2, check battery fluid level, or have it checked when you take your car in for service. 3, check the alternator belt for tightness and wear. Remember, the alternator keeps the battery charged.
Whoa, 1, 2, 3. That's simple enough.
Sure is. But remember, a simple inspection is the best way to keep the electrical system in good shape. In a quality service facility, a certified technician can check the entire electrical system. The battery and charging systems are checked for proper operation. And the technician looks for damage and corroded connections. Sometimes even the battery's platform gets corroded. So the technician makes sure the battery is secure, not wobbling around. Various belts are checked for loose, worn, or cracked condition. Wiring is inspected and tested for proper current flow. And the alternator, voltage regulator, and starter motor are all checked for proper operation. So there you have it, George, your electrical system.
Well, you know, that wasn't as hard as I thought it'd be.
Well, you've learned a lot about how your electrical system works. But when problems do develop, take your car in for professional inspection and service.
Oh, I will. Well, what's next?
How about your ignition and fuel system? The ignition and fuel system's basic job is to provide fuel to the engine and ignite it to keep the engine running.
Sounds complicated.
Well, not if we take it one step at a time. Ready?
Lead on.
Here's a good place to start.
Okay, now I know I have to turn the key to start the engine.
And the ignition and fuel system keeps the engine running. To do that takes three basic things: electricity, air, and fuel.
And the fuel and ignition system get them together somehow.
That's the idea. But let me show you. Let's start with just how the ignition system uses electricity. The ignition switch turns current on or off when you start or stop the engine. The electricity is first provided by the battery.
So where does the electrical current go next?
To the starter motor. After it gives the engine a few turns, the ignition system will take over to keep the engine running. And to do that, the electric current flows to the ignition coil to increase the voltage. The distributor sends that high voltage current to each spark plug.
Yeah, I see them.
Older cars have breaker point distributors, lots of little moving parts inside that eventually wear out. Today's cars use electronics to do the job, with fewer moving parts.
Yeah, I've heard of that. It's called electronic ignition.
Right. In each spark plug, the high voltage current jumps across a tiny gap on the end of the plugs. This spark ignites the air and fuel mixture already in the combustion chamber.
Well, where did that air and fuel mixture come from?
Well, let's first take a look at how fuel gets to the combustion chamber. There's a car. It shows the approximate layout of the fuel system components. Below the car, you can see the function of each component.
So now the fuel travels along those,
Fuel lines. Yes, the fuel is moved through the lines by the action of the fuel pump.
So now the fuel is pumped right into the engine?
Not yet, George. First, the fuel has to pass through the fuel filter. It removes any contaminants in the fuel.
Well, we got the fuel this far, but what about the air? You said earlier I needed an air and fuel mixture.
That's right. Let's go.
You know, I'll never get used to traveling like that. But you never answered my question, remember?
Yes, you wanted to know where the air came from in the air and fuel mixture. Well, George, the engine pulls air in through the air filter. It removes any contaminants in the air as it's pulled in. The clean air is then mixed with a small amount of fuel provided by the fuel system.
Yeah, but what mixes the air and fuel?
Well, there are two ways to do that. Older cars have a carburetor, but most of today's cars use a fuel injection system.
How does the carburetor work?
Well, a carburetor is a complicated device, but basically it's designed to mechanically adjust the proper proportion of air and fuel so the engine can go faster or slower as needed.
So then when I press on the accelerator, I'm actually controlling how the carburetor mixes the air and fuel.
Only if your car has a carburetor. Today's cars usually don't have them.
And that's what you said. So then instead of a carburetor, today's cars use...
Fuel injection.
That's right. In cars with fuel injectors, there's no carburetor.
Right. Instead, the fuel is squirted into the combustion chamber and mixed with the air. Injectors work something like this.
Oh, so the air and fuel is mixed in a nice spray.
Yes, in today's cars, electronics are used to control the fuel injectors so the amount of air and fuel will be just right.
You know, there's so many electronics in cars these days.
True, and we'll see even more in the years ahead. Come on this way. So now, the air and fuel mixture gets to the combustion chamber. That's where it will be ignited by the spark.
Whoa, so that's ignition. What about all that smoke?
Well, that's what's left over after combustion. The exhaust system takes care of it. Exhaust emission controls remove certain harmful gases to reduce air pollution.
Yeah, that's important. But you know, the ignition and fuel system isn't so complicated after all. Everything seems to work together so smoothly.
And to keep it running that way, the system should be checked periodically by a professional service technician.
Isn't there anything I can do myself?
Well, George, you can change the air filter when it gets dirty, but as you saw, there are many parts to the system that should be handled by a qualified professional.
Can you tell me what's involved when I take my car in for ignition and fuel system servicing?
Well, sure. Using computerized test instruments, the technician analyzes the ignition and fuel system's performance. This versatile equipment tests and checks all these things: the charging and starting systems, ignition coil, wiring and current distribution, spark plug output, and the fuel control system. The technician also checks and adjusts the timing.
Whoa, timing. What's that?
It's an adjustment to control the exact time the spark occurs in the combustion chamber. The service technician also checks the distributor cap for cracks and burned contacts, and the electronic sensors for proper operation. The carburetor is checked for proper operation of mechanical linkages. If the engine has fuel injection, the service technician checks the system's electronic injectors and fuel delivery system. The engine idle speed is adjusted as necessary. Air and fuel filters are inspected and replaced if dirty or clogged. As you've seen, George, there's a lot involved in the ignition and fuel system. Professional service will help keep your engine running reliably and efficiently.
Yeah, I see your point.
Pick another dimension, George.
Cooling.
Okay. The cooling system's basic job is to control the heat created by the engine as it runs. Warm enough for efficient operation, but without overheating.
That sounds pretty tricky to me. I know an engine can get really hot after a lot of driving.
Well, every engine has a proper operating temperature. The cooling system maintains that temperature. Let's take a closer look.
Okay. There's the radiator. Whoa, one really big radiator.
The radiator is part of the cooling system. It's what's inside the radiator that's important too. That's coolant. It's simply a mixture of two different liquids, like this: water and antifreeze. Mix the two and you've got coolant.
Well, why is coolant so special?
Because coolant can absorb heat better than ordinary water. The coolant absorbs heat as it circulates through a network of passages in the engine.
Absorbs engine heat. Okay. But the radiator's over there and the engine's over there. So how does the coolant circulate?
Well, that's the job of the rest of the cooling system. Let me show you how it all works. The coolant absorbs the heat from the engine and lowers the engine's temperature.
But doesn't the coolant get too hot to keep the engine at the right operating temperature?
Yes, but fortunately, the system is designed to take care of the hot coolant. See the thermostat? It has a preset operating temperature. When the coolant exceeds that temperature, the thermostat opens and the coolant can flow through it.
Well, what makes it flow?
That's the job of the water pump. It's operated by a belt connected to the engine. The pump moves the coolant along and keeps it circulating. So when the hot coolant is flowing through all those tubes inside the radiator, it's cooled by the air drawn in by the fan. An engine-driven belt runs the fan. In some engines, the fan is operated by an electric motor. In either case, when the engine is running, the fan pulls in air.
The same coolant flows around and around, from the engine to the radiator and back to the engine again. Simple. But there's coolant in there, too.
Yes, that's the coolant recovery tank. It's used to prevent coolant from being lost and to help keep the system pressurized. As your engine runs, coolant in the radiator expands and pressure increases. Instead of being forced out of the system, some coolant flows into the recovery tank. Then, when the engine stops, heat and pressure in the radiator are reduced, so coolant is siphoned right back into the radiator.
So that's why the recovery tank has two coolant level marks on it, hot and cold. It's like a circle. First, the coolant gets hot from the engine's heat, then cooled down, then heated again, then cooled again.
Yes, so you can see why it's important for the coolant to circulate freely.
Well, what happens if it stops flowing?
Trouble. If the coolant stops flowing or freezes in winter, the engine heat will convert some coolant to steam. The steam forces its way out of the radiator through the pressure cap. This means lost coolant. With less coolant circulating, the engine quickly overheats, and that can lead to problems for you.
Hey, what's going on?
A warning light. Any problem with the cooling system is usually signaled by a warning light or temperature gauge. If the warning light does not go off, pull over and park just as soon as you can do so safely.
Then should I open the hood and let the air cool the engine?
Don't open the hood if you see or hear steam or hot coolant escaping from the engine compartment. Wait until neither one can be seen or heard. Another safety point, never take either the radiator cap or recovery tank cap off while the engine and radiator are still hot. Scalding liquid and steam can be blown out under pressure if either cap is removed.
Well, thanks for the warning. Overheating is serious stuff. But obviously, in the winter, I want heat in my car. Is the heater connected to the cooling system, too?
Good question, George. When you turn on the heater, some of the hot coolant is diverted from the radiator and flows to the network of heater core tubes. This warms the air around the heater core. As this happens, a blower moves the warmed air into the passenger compartment.
Well, now that I know how important the cooling system is, I want to keep it running properly. So what should I do?
Check the system at regular intervals, George. Make sure the coolant is at the correct level. Usually, you don't need to remove the radiator cap to check the coolant level. The see-through coolant recovery tank will show it. Check for any leaks in the system. Look at the belts to make sure they're not broken or off the pulleys. You can keep your system in good shape by having a qualified service technician give it a periodic inspection. In fact, the system should be flushed and refilled with fresh coolant as recommended in your owner's manual maintenance schedule. When you take your car in for service, you can have the technician inspect your entire cooling system. The fan belt is checked for wear and tension. The radiator and heater hoses, clamps and mounts are checked for cracks, soft spots, and leaks. The hoses in the system all wear out at the same rate, so if one hose is replaced, it's wise to replace the others. The coolant itself is checked for proper level and cooling effectiveness. The water pump is checked for gasket leakage and any other problems. The thermostat is also checked to make sure it's functioning properly. You know, too often drivers neglect the cooling system until something breaks down. It's one of the biggest causes of problems on the road.
I know what you mean. With my luck, the old cooling system will break down on either the hottest day of the summer or right in the middle of a blizzard.
Well, you've learned a lot so far, George. Something tells me you'll be paying more attention now when it comes to keeping your car in good condition.
You know, maybe I am getting just a little smarter when it comes to how my car works.
Good. Time to pick another dimension.
How about steering and suspension?
Okay. The steering and suspension systems work together. Steering enables you to change directions and follow the road. The suspension system supports the weight of the car, keeps the wheels in contact with the ground, and isolates the passengers from the rough road. Let's take a closer look. This way.
I'm right behind you.
There are two different types of steering designs, conventional and rack and pinion. Let's look at them side by side. On top is the parallelogram or conventional steering. The other is rack and pinion. Notice anything different?
The one on the bottom looks less complicated.
Well, that's because it is, and that's an advantage.
I see. I just turn the steering wheel and the system components do the mechanical work along with the gears and stuff. But what about power steering?
Power steering uses pumped fluid to reduce the effort to steer.
That's why they call it power steering. Fluid pressure helps turn the front wheels.
That's the idea.
Okay, I understand how steering aims the car. But how does steering work with the suspension on a car moving down a rough road?
Well, first you have to know more about the suspension system itself. The basic suspension system is made up of control arms, joints, springs, shock absorbers, and tires. Together, they help absorb the shock of the bumps, stabilize the ride, and keep the tires on the road. Another version of the suspension uses a design called McPherson struts to replace the upper control arms, joints, and shocks.
That really looks like compact construction.
Yes, and that's one reason why it has become the most common suspension used in today's cars. McPherson struts are used on front-wheel drive cars, but they're also found on rear-wheel drive cars for either front or rear suspensions.
So what's the difference between front and rear suspension?
Well, the front suspension keeps the wheels at the proper angle to the road and at the same time allows the wheels to turn so the car can be steered. Because you don't steer with the rear wheels, the rear suspension is a little simpler. The rear springs may use a leaf design instead of coils.
You know, I never thought about tires being part of the suspension system.
Tires are important, George. They do more than just cushion the ride. Properly inflated and maintained tires help grip the road with good traction and good control. Tires designed primarily for wet or snow-covered pavement have deeper and larger treads. But today the trend is toward all-weather radial tires. Radial tires provide improved traction and a quick steering response.
Oh yeah, I see what you mean. Tires can have an effect on steering.
But alignment is also very important.
Alignment?
Good alignment means that the wheels, frame, and other steering and suspension components are all at the proper angles to each other. That makes a car easier to handle because it will travel in a true direction and also minimizes wear on the tires. The alignment goes out of adjustment partly as a result of natural wear in the steering and suspension joints and partly from all those hard bumps and potholes the tires hit.
So then the alignment gets all shaken up and has to be readjusted.
Precision alignment is performed by a certified technician. The tires, steering, and suspension components are adjusted to the proper angles. While a front-end alignment can correct some problems, most cars really need a four-wheel alignment. This positions all the wheels for safe, accurate steering, stability, and optimum tire wear. So see, alignment service is very important, but you can be on the lookout for symptoms of problems.
Hey, now where'd that come from?
I think we've just seen a symptom. Let's take a look. Ah, see? There's the leak.
Well, is that bad? I mean, after all, it's not a very big leak.
Well, leaking and worn strut components can lead to suspension problems. This will have to be replaced.
Okay, leaking struts. That's one thing to watch out for. But what about all the other stuff we looked at?
Well, just the way your car handles tells a lot about the condition of the system. For example, excessive play in the steering wheel, hard steering, or unusual sounds when the wheel is turned. All these indicate there may be a problem in the steering system. A service technician can pinpoint the problem and adjust or replace any malfunctioning component. To help keep the parts working smoothly, the system should be lubricated.
Sounds like taking my car in for service is the best way to avoid steering and suspension problems.
Yes, and when you do, the technician checks the shock absorbers and struts, all steering components, linkages, and bushings. Other checks include tire tread wear and tire pressure. Rotating the tires helps each one wear evenly. Tires should be balanced so they won't wobble, bounce, or vibrate at high speeds. If a car has power steering, the power steering pump fluid level, drive belts, and hoses need inspection. The technician will also make sure the suspension keeps the body at the proper height according to the manufacturer's specifications. Professional service will keep your steering and suspension system in great shape, George. But here's something that will help.
Well, that's just a tire pressure gauge.
That's right, but consider it a good investment. Keeping your tires properly inflated is the easiest way to keep them in good condition.
Thanks.
We've got more to see. Choose another dimension.
Brakes.
Okay. The brake system's basic job is to slow and stop the vehicle safely.
Well, there's no need to stop now. Let's take a closer look. You know, my car is really heavy, but I can stop it easily just by pushing down on the brake pedal. How's that possible?
Well, brakes use friction to stop the turning wheels.
Hey, what's that bicycle for?
Watch, George. The lever pulls a cable connected to those rubber pads. Squeezing the lever forces the pads against the wheel rim. Friction stops the wheel. Your car brakes do much the same thing. Apply friction to each of the wheels.
Yeah, but they have to be more complicated than a set of bicycle brakes.
Well, why don't we take a look? Understanding your brakes may be easier than you think. There are two basic types, the drum brake, here, and the disc brake. They're different, but both use friction to stop the wheels. This is the disc brake. It has two basic parts, the rotor and the caliper assembly. Pushing the brake pedal forces the two brake pads inside the caliper against the rotor. This creates the friction to stop the wheels. It works just like the bicycle brake. In the drum brake, the basic parts are the drum and the brake shoes. Here's how it works. When you press the brake pedal, the brake shoes push against the drum and create friction between the shoe lining and the drum surface. This friction slows the drum until the wheel stops.
I get it. Shoe pressure won't let the wheel turn because of the friction.
That's right. When you let up on the brake pedal, springs pull the brake shoes away from the drum. The wheels can then turn freely.
Okay, but how do I get all four wheels to stop at once?
Well, the system relies on brake fluid to operate the actual brake parts on each wheel. When you press down on the brake pedal, you move a piston in the master cylinder, which causes fluid to move through the brake hoses and lines to the wheel cylinders and calipers.
So that's how it works.
It's the same principle in your car, George, so you can see why leakage anywhere in the system leads to trouble with the brakes.
No fluid, no brakes.
It's important to have the brake system inspected and serviced regularly. From a safety standpoint, it's the most important system in your car. Any defective part, no matter how small and seemingly unimportant, should be replaced at once.
Well, what about power brakes? How are they different from regular brakes?
Well, power brakes have a special booster unit in the system. Power brakes don't stop the car faster, they just make it easier to push down on the brake pedal.
Well, I want to keep my brakes working properly. Can you give me some symptoms of possible brake problems?
You can be on the lookout for any unusual sounds when braking. If the brake pedal seems to feel different, or if the car pulls to one side when you brake, you need to have the system checked for fluid loss or even possible leakage from the brake components. To help your brakes last, don't jam on the pedal unless it's an emergency stop. And don't ride them by keeping your foot on the pedal while driving.
Next time I'll be more careful when I drive. But is there anything I can do to keep my brakes in good working order?
Well, George, checking the brake fluid level periodically is part of good routine maintenance. And remember, if the level is low, add only brake fluid, never any other type of fluid. But a certified service technician is really the best person to inspect and maintain your brakes. This means an inspection of the entire system, including components that affect it, like wheel bearings and grease seals. Other related parts may also need replacing, such as weakened springs, leaking seals, and stretched cables. Brake lines and hoses are inspected carefully for damage or leaks. The master cylinder is checked for external leakage, and the brake fluid is also checked for condition and proper level. Brake pads take the most wear. They need to be replaced if worn down or gummed with oil, grease, or brake fluid leakage.
Well, you know, I've learned two things for sure. There's a lot more to the brake system than just the pedal. And you can't cut corners when it comes to maintenance.
That's right, George. You've seen how your brakes work and how important they are, so let's keep them in good condition.
Well, what's next?
How about preventive maintenance?
Good.
Preventive maintenance includes checks, adjustments, lubrication, and parts replacement, all to keep your car running smoothly and safely. There's much preventive maintenance you can do yourself, but some people prefer to leave it all in the hands of a professional. Either way, preventive maintenance helps lower the cost of operation and extends the life of your car.
Boy, I'm for that. I've invested a lot of money in my car, and I want it to last.
A car is a big investment, usually the second biggest a person makes. Proper preventive maintenance is the best way to keep that investment on the road. Why don't we take a look inside?
Why not? Hey, this looks like a little bit of everything.
And you'll want to keep everything in good working order, George. Poor performance in your car can be caused by little things: low oil, underinflated tires, dirty filters. A poorly maintained car, whether old or new, burns more fuel, and neglecting oil changes can lead to expensive engine work later on. Proper maintenance of tires and brakes is essential to driving safety.
Well, I agree that preventive maintenance is important, but I get a little confused about what I should do and when.
I understand. First of all, preventive maintenance should be done according to a routine schedule. Your owner's manual has a recommended maintenance schedule for your car.
You mean I don't have to take my car back to where I bought it for maintenance?
Well, that depends on what needs to be done, especially if anything's under warranty. So it's a good idea to read your car's warranty and owner's manual for recommended maintenance. Some maintenance you can do yourself, but there are many things that should be done by a service professional.
What kind of preventive maintenance can I do? I'm not very good with tools.
Well, George, you have two very good tools to help you, your eyes and ears. Check the battery fluid level. Keep the terminals clean and make sure it's firmly seated in its frame. Inspect the alternator belt for cracks or worn condition. By the way, never check the belts when the engine is running. Check the air filter, and if dirty, replace it. Coolant should be checked for proper level and for any rust that would mean the system needs flushing. Inspect hoses for cracks, swelling, and leaks, and the clamps for corrosion. Tires should be kept at proper inflation. Look for signs of excessive tread wear. This means you may need alignment or tire rotation. Check the brake fluid level periodically. Preventive maintenance also includes checking the oil level after the engine is warmed up. Dirty oil means an oil change is needed. Your owner's manual shows the right type of oil. You should also check the power steering fluid level. Check the level of the transmission fluid with the engine running. Don't forget to check the windshield washer fluid regularly. Good visibility is important in bad weather. Wiper blades deteriorate, so annual replacement is a good investment.
That's a lot to remember. I think I should have been taking notes.
Don't worry, George. Your owner's manual has preventive maintenance schedules for your particular car. If you prefer, a qualified professional can do routine preventive maintenance when you take your car in for service. In addition, preventive maintenance and repairs can overlap. For example, computerized test equipment is used to analyze the ignition system condition and pinpoint any problems. The cooling system components are checked and adjusted. Periodically, the coolant is flushed and changed. To prepare for cold weather, it's important to winterize the cooling system with the proper antifreeze mixture. The steering and suspension system components are checked, adjusted, and lubricated. Another job for a professional is strut and shock absorber replacement. If the car sways on turns or bounces excessively when you apply the brakes, it may be time to replace your shocks. Poor shocks can also contribute to uneven tire wear and shorten the life of your tires.
Yeah, I see what you mean. What else does professional maintenance involve?
Well, there's plenty that your service partner can do to help maintain your car, George. Tire rotation, tire balancing, wheel alignment, oil change and oil filter replacement. A quality service facility can provide a variety of maintenance services to help keep your car running smoothly.
What about my brakes?
Brake service includes checking brake shoe wear and, if required, a brake overhaul. The service technician will also check for low brake fluid and change it if needed.
So then preventive maintenance is really just regular inspections and routine care.
Yeah, there's no mystery to keeping your car healthy, just preventive maintenance and regular service. But George, always observe basic safety precautions when checking your car's systems. For example, when looking under the hood, always stay clear of fan blades and moving belts. Keep neckties or loose clothing away from the engine. It's best to have the engine switched off, but even if the engine is off, electric fans may start up, so be careful. If the engine has been running or is overheated, don't attempt to take the radiator cap off. You could get burned by the escaping steam or hot coolant. Never smoke while checking the engine or battery. You might accidentally ignite a fluid or fumes and cause a fire or explosion. For more about safety, George, consult your owner's manual. You can also talk with a service professional. That's a good way to avoid damage to your car and injury to yourself.
Well, thanks for the suggestions.
Well, you ready to move on?
Yeah, let's find out about your service partner. You know, I'm not sure that's so funny. More like a bad dream.
Well, that's the point, George. Selecting a service facility should be done before serious repair problems develop, not after.
Hey, this doorway doesn't seem to lead anywhere.
Well, that's because where it goes is really your decision, George.
My decision? Yeah, I guess you're right. But how can I be sure if I'm making the right decision on where to take my car for service?
Well, this can help you.
Measuring tape.
Right, but it's not the ordinary kind.
Somehow I can believe that.
George, there are only 3 basic guidelines you need to look for when selecting a quality service facility.
3 guidelines. Hey, look at this. Properly trained technicians. That's one guideline?
Yes, and a very important one, too. You want service technicians with up-to-date knowledge about your vehicle and its many systems. Certified technicians trained to use diagnostic equipment and tools.
There's more. Proper equipment.
Very important. To do a proper job, the service technicians must have the proper equipment, including the most modern computerized diagnostic tools.
And this, integrity to stand behind their work.
Yes, with a specific warranty to back all work they do. Isn't that the real measure of confidence, George? That's the kind of integrity customers expect when they select service facilities associated with national companies.
3 simple guidelines. Hey. So, if a service facility doesn't measure up, then it's not for me.
Okay, but after you've selected a service facility, you've got to do your part too.
My part? I thought all I had to do was choose the right facility and they'd do all the work.
Well, George, as the driver and owner of your car, you can help more than you realize. Here's what I mean. You and your service facility are partners, George. You can work together to write up the service order.
Wait a minute. I'm no expert on cars, so how do I explain the problem?
Well, you don't have to diagnose the actual problem yourself. That's the professional's job. Your job is to give the symptoms. Explain the problem in your own words.
You mean like I hear a squeaky noise every time I press the brake pedal?
That's right. Try to include when the symptom occurs and in what situations.
Like when turning corners or when slowing to a stop.
You've got it. You can help pinpoint problems if you use descriptive words about any odd sound, odor, or even the feel of the car as you drive. Any notes you've written as a reminder will also be helpful. Good communication is essential to good relationships, George. Make sure your service partner accurately understands all the information you've given. And George, always leave a telephone number where you can be reached.
Okay, but how do I find out about things like service policies and warranties?
You can expect a quality service facility to have procedures guided by certain standards. Your service person should automatically inform you about their various policies and warranties. And of course, it's a good idea to ask for a copy of the warranty before any repair work is done.
Anything else I should ask about?
Ask for a reliable written estimate of work and parts. Check to see if parts and labor prices are posted in the facility. You'll want to know when work is to be completed or if appointments are available. Ask about the service policies. Do they accept major credit cards or do they have their own credit card available? Written warranties should be provided. After work is completed, the worn-out parts should be returned to you. Of course, you really shouldn't have to ask. The information should be freely provided by the service person. After all, isn't that what service is all about? Good service for you and your car?
You know, I never really thought about it like that before. I guess I thought service was just another problem I'd have to deal with, like a flat tire. But it doesn't have to be a problem if I just choose the right service facility. One where customer service is just as important as servicing my car.
Ready to go on?
Wow.
Only one dimension remains for you, George. You've finished your tour.
Well, I certainly know a lot more about my car now than when I first arrived.
Good. Then Auto Dimensions has served its purpose. George, from now on, you're in the driver's seat.
Well, thanks for the tour, but how do I get back? Whoa! Hey! I am back!
George, I think I know what the problem is.
Thanks, Ralphie, but I know where I can get the problem solved.
You do?
Yep.
Wait, George. I can take care of this for you. Give me a chance. I'll go get my tools.
Goodbye, Ralph.
Bye, George.